Hello, today I am going to discuss about the lacing systems. Lacing systems are used basically to keep the built up sections throughout its length with an equidistance. That means, the built up section whatever we used throughout its length, we need to tie them to make them parallel and to make them equidistant and to make them act as a monolithically, so that as a whole the built up section works. So, for that we may use lacing, which are basically some inclined member between the two compressive means vertical members, or maybe batten system. Batten system is basically the horizontal plate which are connected with the two main members. These are called batten members, but today we will be discussing about the lacing members, which are basically the inclined members, and these lacing members are used when when compressive loads are acting or the eccentricity is there. Especially for eccentric loading, we prefer lacing system. Now, for lacing system, the lacing members are generally flat plate, it may be angle section, it may be light channel section, or maybe circular section, means tubular section. So, different way we can provide. Now, in case of lacing member, again we can consider two type of lacing member. Say this is one member have been provided, this is one compression member, this is another compression member, which are used for built up section, and we are providing lacing. So, we can provide as a single lacing, this is called single lacing system, or we can provide double lacing also. In case of double lacing, it will be like this. Right. So, in different way we can connect, of course, maybe separately we can connect, maybe this can be connected together. So, this is called double lacing. So, when we will be designing, we have to first decide whether we are going for single lacing or double lacing, because accordingly the force on lacing member will come into picture, that has to be taken care. Now, when we be going for designing of a lacing, we need to know what are the failure modes of the lattice member. So, what type of failure may happen, that we will first see, and accordingly we will try to develop a design methodology, so that the failure can be arrested. So, in case of one is buckling of built up member as a whole, buckling of built up member as a whole. That means, if as a whole, if column is very slender, then it may buckle like this, right. It may buckle like this under, if column is very slender and if axial load is much high, then the buckling may happen in this way. So, this is one means one way it may fail. Another way it may fail, that buckling of main component, buckling of main component. Buckling of main component means, maybe we are providing say a compression member here, and we are providing a compression member maybe here, and we are providing certain lacing system, right. So, what you could see, if the loading whatever it is coming, for that if the member is not able to carry that much load due to buckling, means excessive buckling, then it may fail. The main component, because say if we see the cross section, the main component, say if we use channel section, the minimum radius of gyration will be about y. So, the failure may happen about this section. So, as a local failure, this can arise, buckling of main component. Then another way of failure is the distortion of the section. The section may distort. Say for example, this is a built up section where lacing has been provided. Now, if we see, if distortion happens, it will be something like this. So, due to distortion, the failure may happen, which has to be taken care. Another failure is, this is number 3. Number 4 is the failure of lacing member. Means lacing member whatever we are providing, that has to be also taken care. Say for example, if we provide 2 built up sections with the lacing, say if its width is less compared to its length, then it may buckle like this. Say a member may buckle like this, right. So, this is called failure of lacing member. So, 4 type of failure may come into picture. Now, what we need to do is that we will design the lacing system in such a way that that it will arrest the failure of local buckling, it will arrest the failure of lacing system, and it will take care the failure of member as a whole, means globally, and also distortion. So, what we have to consider, say for example, how do we consider the say this one, say this is called L. So, L by RC minimum, means L by RC minimum. So, radius of gyration should be limited, because otherwise this may fail. So, some restriction we should provide. The slenderness ratio is restricted, and to restrict the slenderness ratio we have to restrict the length. That means, spacing between 2 lacing has to be decided. So, from failure of local buckling we can find out what should be the maximum distance between 2 lacing L. So, this is what we have to decide. Another thing is, when the failure of lacing member happens, say for example, for this, that means the lacing cross section is not sufficient to take the slenderness, means to take the load, that is why it is buckling. So, therefore, the what should be the width of the lacing member, what should be the thickness of the lacing member, that has to be decided, from which the slenderness ratio has to be calculated. So, that also we need to take care. Next is the failure as a globally it may failure. So, if global failure happens, that means we have to see that if we have 2 sections we are providing, then we need to take the section spacing in such a way that we are under the limit of the slenderness ratio. That means, the slenderness ratio of the built up section should not exceed the limiting value, that has also to be decided, right. So, now coming to the general requirements which has been given in the code. This is given in clause 7.6 of IS 800/2007. Here it says that the compression member comprising of 2 main components, laced and tight, should where practicable have a radius of gyration about the axis perpendicular to the plane of lacing, not less than the radius of gyration about the axis in the plane of lacing. So, this has to be taken care. Therefore, that as far as practicable, lacing system shall not be varied throughout the length of the strut. That means, the lacing system, the lacing spacing and lacing dimension, those things should not be varied along its length. That also has been mentioned in the code. Now, coming to the single lacing system, we have, say for example, we have a channel section, say toe to toe. Now, we will be providing lacing here and we will be providing lacing here. This is say called face A and this is face B, right. Now, the preferred orientation should be like this. That means, one should be the shadow of the other. If this is provided in this way, then the other in other direction should be provided in this way. So, it should be the mirror image of that, right. It should not be means such type of orientation are not preferred. So, this is also mentioned in the code. We can see here that the preferred lacing arrangement, lacing on face A and lacing on face B has been made. So, one is shadow of the others, and this is given in the IS 800/2007 and figure number 10A. And in figure 10B double lacing system, how the preferred lacing arrangement should be, that has been also mentioned here, that when double lacing systems are there, means it is preferable that you make a bolt connection here, that means you tie it, then it will be much more effective, and the face A and face B should be in this way. So, that the arrangement will be, means as per codal provision, the facing means lacing on face A and face B should be like this. That means similar, identical to each face. Then another things is told in the code, which are mentioned in the code, is that double lacing system and single lacing system on opposite sides of the main component shall not be combined with cross members perpendicular to the longitudinal axis of the strut, unless all forces resulting from deformation of the strut members are calculated and provided for in the lacing and fastening. So, this is what in the code it is told. Also, we should keep in mind that when we are providing lacing and means with combined cross member, then in such way one can provide, say double lacing system, then cross member, double lacing system, then cross member, like this. Or if we use single lacing system, one inclined member, that is which is called lacing, then one cross member, like this it is preferred. Now, coming to design specification. In design specification, first it is told that the total transverse shear force V will be the 2.5% of the compressive force P, because in lacing, when we are going to design a lacing, lacing will be undergoing some compression in one member, in other member it will be tension, and that means some forces will be acting here. That force will come from the transverse shear force, and that transverse shear force is calculated from the axial compressive force, and in codal provision it is told that the transverse shear force should be 2.5% of the compressive force. Next, if we distribute the load, means force on the lacing, we can see here that for a single lacing system, if we see that we know that this is the angle of inclination, we can consider as theta with the vertical angle, and the total transverse shear force is V, then in each phase it will be V by N, because in two phase it may have in two phase or number of phase may be increased. So, depending on the number of phase, the shear force in each cases will be V by N, right. And if this is V by N, and if the force acting on the lacing is F, then we can find out F sin theta, means V is equal to F, this will be F cos theta and this will be F sin theta. That means F is equal to V by N, that means F will become V by N sin theta, right. So, F will become V by N sin theta, and if number of parallel plane is 2, for single lacing it is generally 2. So, V by 2 sin theta. Here N is the number of transverse system in parallel plane. Now, for double lacing it will again divided by 2, because it will be distributed in 2 cases. So, F will become V by 4 sin theta. Now, as I told that this force will be tensile in one bar and compressive in other bar. Now, as I told, the lacing member may buckle locally, this lacing member may buckle, right. So, the code has provided certain restriction, which is given in tabular form here, that the what will be the effective length and what will be the slenderness ratio. The slenderness ratio, it is telling that the L by R of the lacing bar should not exceed 145. That means, as per the codal provision, we have to make the dimension of the lacing system in such a way that L by R should not become more than 145. So, that has to be mentioned, and to calculate LE, the effective length, that has been also discussed in the code, that is, in case of single lacing with bolted end, LE will be L. That means, L is the length between inner and end bolts of lacing bar. So, LE will be L, and for double lacing bolted at ends and intersections, it will be 7 L, where L is the length between inner ends of bolts, right. And for welding lacing also it will be 0.7 L. So, the effective length for different cases has been defined in the code, which is shown here. In single lacing it will be LE is equal to L, in double lacing it will be 0.7 L, and in welded case also it will be 0.7 L, and the slenderness ratio should not exceed 145. Now, if we use flat bars, then what should be the restriction, means lambda lacing, how do we calculate? So, lambda, as we know, LE by R, right. So, LE by R, if we calculate, this will become LE by I by A, square root of I by A, that will become LE by square root of I by A, means BT cube by 12 by BT. This will be, so finally it will be LE into root over 12 by T, right. So, lambda lacing means lacing in the means slenderness ratio of the lacing bar should be LE into root over 12 by T and should be less than 145. So, this is how from here we can find out the value of T. The thickness of T also can be found from here, right. Then the okay, R here it will be I by A, root over I by A. Now, width of lacing bar. Now, how do we find out the width of lacing bar? Width of lacing bar means what will be the width of this, if lacing bars are provided. So, width of lacing bar, if we say B, then in bolted and riveted connection, the minimum width of lacing bars should be more than 3 times the nominal diameter of the end connector. That means, B should be more than or equal to 3 into D. The width should be minimum 3 times D. D is the diameter of the bolt or rivet. Then coming to thickness. Thickness, either we can find out from that the slenderness ratio value, or at the beginning we can find out the thickness from this criteria and we can check for slenderness ratio. So, in case of single lacing, it is suggested that T should be greater than or equal to L by 40, and for double lacing T should be greater than L by 60, where L is the length between the inner end bolts. That means, if this is lacing bar, then if this is bolt, then this will be the length, right. So, the minimum thickness of the lacing bar can be found from this criteria. For single lacing it will be L by 40, and for double lacing it will be more than L by 60. Then another important thing we have to find out, means we have to decide, that is the angle of inclination of the lacing bar. How do we decide? That can be decided, means as Codal provision says, it should be between 40 to 70 degree, right. If we have a lacing here, then the angle of inclination with the vertical member should be between 40 to 70 degree. However, it is from the experience it is seen that this lacing system will be effective if theta becomes more or less 40, means near to 40 or 45 if we consider, or means basically 35 to 45, then it will be much effective. Then spacing. Spacing means the distance between two lacing member, which is called spacing, that L, and this spacing, because this may buckle like this locally. So, to take care this buckling, the Codal provision has told that the maximum spacing of lacing bar should be such that minimum slenderness ratio should be 0.7 lambda max or 50, which is minimum. So, in any case it should not exceed 50 and it may be 0.7 lambda max as well. So, spacing of the lacing bar has to be this to take care the local buckling of the column, right. Here L is the distance between center of connections of the lattice bars to each component. Now, what is RC minimum? RC minimum is the minimum radius of gyration of the component of compression member. That means, if we use say channel section, then RC minimum will be the RYY. RC minimum will be RYY, right. Then attachment to main member. Now, we need to find out certain number of bolts or welding dimensions for attachment of lacing to the main component, right. So, that will be dependent on the what is the force coming in this lacing member. Depending on that, the number of bolt will be decided, or if we use weld connection, the length of weld connection and size of weld connections will be decided. So, the Codal provision says that the riveting, bolting or welding of the lacing bars to the main member should be sufficient to transmit the load in the bar. Then, in case of weld connection, it is told that where welded lacing bars overlap the main members, the amount of lap measured along either edge of the lacing bar shall be not less than 4 times the thickness of the bar or the members, whichever is less, and the welding should be sufficient to transmit the load in the bar and shall in any case be provided along each side of the bar for the full length of lap. So, this is what we have to remember in case of weld connection. And for bolt connection we have to provide, means we have to find out the strength and number of bolts. So, in case of such type of member, means such type of connection where connections are made separately, then the number of bolts can be decided as F by R, where R is the bolt value, right, and F is the force on the lacing member. So, if we know the force on lacing member, then we can find out the number of bolts required for this. So, this is how we can calculate, but for second case, in this case we can see that both the members are acting on this bolt, right. So, the resultant force we have to find out in this. Resultant force will be, if we see this, the resultant force will be F cos theta plus F cos theta, right, this is theta. So, 2 F cos theta will come into picture, and this is F sin theta and this is F sin theta, which is nullifying. So, 2 F cos theta will be the resultant force, and bolt value if we consider R, then 2 F cos theta by R, right, where theta is the angle of inclination and F is the force in the lacing bar. So, if we find out the force in lacing bar, then we can find out the number of bolt required to connect the lacing bar with the main plate, and this depends on what type of connections we are going to consider, whether it is separately connecting or it is overlapped. Two lacings are overlapped and acting as a double shear. So, here also you can see that the bolt value of this case and bolt value of this case will be different, because here the bolt value will be under single shear and here the bolt value will be under double shear. So, accordingly the bolt value has to be calculated. So, these are the things we have to remember while we will be going to design a lacing member. So, in short, if we say that lacing members are designed or the entire built up sections are designed on the basis of failure criteria, failure of the member as a whole. So, we have to restrict the radius of gyration, so that failure does not occur, failure of the main member locally, that also we have to provide the lacing spacing, that L, capital L, in such a way that L by RC minimum should not exceed certain value, right. Then again there will be a chance of failure of the lacing member itself due to heavy force or due to slenderness. So, that also has to be taken care. We have to see what is the strength carrying capacity of the lacing member, and we have to see what is the radius of gyration and what is the slenderness ratio is coming, and we have to restrict within the maximum slenderness ratio which are permissible, means within the permissible slenderness ratio. This is what we have to do. Also, we have to find out a suitable arrangement of bolt or weld connection for attaching the lacing system into the main members. If we use bolt connection, then again we have to see whether we are connecting the lacing member separately or we are overlapping that. Accordingly, the forces will be calculated and then the number of bolts will be calculated. And in fact, if we see, the force on the lacing member is quite less, and generally number of bolt becomes 1 to 2. In maximum case we will see 1 and sometimes we will see 2, that is sufficient. So, through workout example we will also confirm this. Okay. So, this is what today we have discussed, and in next class we will discuss about the steps, whatever we have discussed today, how to design step wise, means in a systematic manner, that will be discussed, and then a workout example will be done. Thank you.